All right, welcome everyone to our 11 a.m. session. We are joined by Bhavin Shah, who will be talking about how conversational AI will empower 1 billion knowledge workers. So Bhavin is the CEO of Moveworks, and we're really glad to have him with us. Welcome, Bhavin, and thank you for joining us.
Thank you for having me, Irene. All right. So I think, as the title says, we are going to talk about how conversational AI is speeding up the lives and the productivity of knowledge workers worldwide. And clearly from today's conference, you're hearing about how AI is no longer just a theoretical thing, but something that's being practically used in lots of different applications. In the enterprise specifically, AI has quadrupled in over just the last 5 years. And really, the unlocking of this potential in the world that I come from, in the world that Moveworks is in, is conversational. And that means that it requires a seamless integration between the interactions between us and these machines. If you ever call the customer service hotline and talk to a robot, you'll know how badly those interactions can go. There's really only one seamless UI that we're all comfortable with, one that we use to talk to other folks about things that we need, and that is conversation. And so today I want to share some of the biggest leaps forward in conversational AI and natural language understanding. And finally, talk about how truly conversational AI will mean in terms of impacting the work that you do and the work that we all do in our daily lives at the office. Now, in terms of what is a knowledge worker, let me just begin to clarify that a bit. According to Gartner, there's 1 billion knowledge workers worldwide. And what that means is folks that drive their work from thinking. Folks that are probably more like yourself and myself here on this conference. And there's a recent study that was done of knowledge workers just last month in June, where they surveyed them and asked them, could you do most or all of your work remotely? And the resounding answer was yes. And so you could see here across lots of different verticals, knowledge workers are actually faring fairly well in the sheltering in place that we're all experiencing, despite not having access to the office or other equipment. Now, what happens though is with all of this new technology that we're using to go about accomplishing our tasks and doing the work that we need to do, there's been an explosion of tools. There's been an explosion of SaaS. For a company of 1,000 employees, they're on average seeing about 200 applications that employees are using. And by using so many applications, employees are also less familiar with those applications. I think our marketing department at Moveworks alone uses 40 different tools to help broadcast and communicate and to market our products. And so to stay productive, knowledge workers need to be facile at these tools. And that's where IT support comes in and why this is so central and such an interesting topic. With each of these tools that we're using, we're less familiar. We're not using them 100 hours, a month. We're using them a few hours here and there. So we might forget, how do you reset that? How do you open this? Where do I access this report? Can you get me off this distribution list? Can you do these things? And these tickets that are solved by your IT departments worldwide are taking 3 days on average. And so we looked at this problem and we've dug even further. There's 700,000 unfilled IT jobs in the US alone. This is pre-COVID. And so IT teams weren't able to staff up enough even before this pandemic to draw down these hours to make it happen in just a few minutes or a few hours instead of 3 days. And so this is where a new approach needs to be taken. And AI and understanding language can actually have a pretty meaningful impact here. And this is what we're going to talk more about. As to why language understanding can unlock this. Well, to begin, I want to talk about why language understanding is so hard. Let's start with, sort of the data problem. When we think about, natural language understanding, we think about large consumer companies like Google or Amazon. They always come to mind. And these giant companies have the advantage of big data, right? 3 trillion unique web pages, 100 billion searches a month. But if you think about solving this problem or solving the problem related to language, which is search, in the IT or the enterprise setting, for 1,000 employees, they only have 100 laptop issues and 10 VPN connection issue tickets come in. Very hard to train off that, very hard to build systems that are smart with that kind of small data. Furthermore, when you have lots of data, you can use probabilistic approaches. Google's technology is obviously far more complicated than the simple search bar implies. But with chatbots in the enterprise, what you've often seen is that these things rely on hard-coded logic. Why? Because there's not enough data to know which way things will tend to go. So they get hard-coded. And these things end up getting stuck in endless loops, and the conversations are scripted, and then people sort of lose faith. People lose interest in using these things. And that's really where you can't just take the complexity of language and assume you can simplify it down and get good results. This is exactly what the systems out there you see often are doing, and that sort of is why they often get stuck. So here's an example of what happens when you have lots of data and you have the advanced techniques. People might be asking how much muscle gain can you gain in a week, or perhaps in shelter in place, they're asking how much muscle will you lose in a week by not exercising. And Google comes back with a great answer, a snippet right at the top. It uses a lot of techniques to do this. Now, imagine if Google tried to hard code this and sort of anticipate every possible search query and sort of build a knowledge graph of every possible answer. That becomes intractable. And early days of internet search, people tried to categorize and classify these things, as we've all experienced. In the enterprise, though, it still relies on those old techniques of keywords and phrase matching, and as a result, gives you unpredictable results. How do I set up my Java environment? Comes back with something not related at all. And when we switch over to kind of the deep learning world and the machine learning world that's getting all the press and the news these days, these techniques have also involved lots and lots of data. From text recognition in the 90s to face recognition last decade to autopilot using billions of miles of sensor data. That's the advantage of large data. But I go back to the fundamental question, which is, well, if you want to do something to impact knowledge workers, if you want to create the future of work, you got to tackle this issue of not having enough data to process, to be able to automate and learn from. So I'll walk through a few interesting techniques and kind of changes that we're seeing in the industry, but just a quick understanding of who we are at Moveworks, and to give you some context, we're about 150 person company headquartered in Mountain View, though of course, just like all of you, we're sheltering in place, staying safe. And we've really been at this from the perspective of knowing how these systems were built in the consumer world and bringing them to the enterprise. And we knew that those differences that we see every day aren't set in stone. We know that if we could create a true conversational system with the key ingredients that we'll talk about, we could dramatically improve the workday and allow some of these routine tasks that all of us engage in to stay productive, to become very seamless and fast. Let's talk about IT support in a little bit more detail. So just some understanding, employees worldwide, knowledge workers, submit about 1 ticket a month to their IT department, or in other words, 13 tickets a year. You probably didn't think about this, but you're going to probably send more more IT support tickets than you will customer support tickets in your lifetime, simply because you're always getting new laptops, new phones, new applications, new devices, getting access to reports, wanting to be added to a distribution list. All these different things show up. And when you submit those tickets, you tend to write a quick email or a quick note to IT, fill out a quick form, and it takes on average 3 days. And largely because this is a language problem. It takes time for someone in IT to read what you said, then organize their work so that they can go fulfill the task. But what if machines could do this? How can we create machines to do this so we could speed this up? Well, let's start with the fundamentals. I need a new laptop. Seems pretty simple. You can use a lot of libraries out there, a lot of tools out there to understand what that sentence is all about. The intent of that sentence, the entities in that sentence, that can be broken down. In 2020, that's an easy problem. What's a hard problem is this. Employees submit the darndest of things to IT, and they'll say whatever feels natural to them. They'll say, hey, I've been at MIT for 4 years as a professor, and it's time for a refresh, I think. They never said hardware, they never said laptop, they never said PC. There's a lot of guesswork that has to go into it, though a person might understand immediately, okay, let's fill out this form, I can get you set up. So this is inherently the problem. And when you get deeper into this, if you can understand this, if you get the data, you can actually start to create very intelligent and smart things and systems, like what you're seeing on the screen here. Here's someone chatting with a Moveworks bot, and they asked for something fairly complex. They're just starting to use MS Office. I don't know how to get a license. Any suggestions? That's a lot of words. You put that into Google right now, not going to get a good answer. But a system that's been built around this can understand, okay, you need Office 365, or I think Microsoft now calls it Microsoft 365. And it comes back, confirms it with the user, and then it does the work right there in just a few seconds. At 11:30 at night on a Saturday, no matter what time of day, systems like this can be performant and can drive results. Today, systems like this, our system in particular, is resolving about 40% of all IT support issues end to end with no agent intervention. And that's because we've taken this machine learning approach that deals with this small data problem and continuously improves over time. So now that gets me to kind of the core ideas that I wanted to share today. And that is, how do you build a conversational AI system? Well, to do that, you need to understand what employees want through natural language and deal with the fact that there's not a lot of data out there. And you need to be able to resolve these issues in natural conversations because employees will oftentimes switch their context and change their mind in midstream. And you have to be able to sort of keep up and understand. Okay, so let's talk about machine learning with small data. Everything we talk about usually with machine learning is lots of data, lots of data, lots of data, but this is what we're dealing with. For a 2,000 person company, believe it or not, there's 24,000 tickets that get submitted by those employees every year. That's a lot of downtime. That's a lot of issues that IT needs to get on fast. Otherwise, that company is not going to get to its goals. And so, if you think about 3 days per ticket, that's a real slowdown in the overall productivity. But now when we look at the data, what you'll see here is if you want to train IT systems to learn how to deal with VPN setup issues, you've got 10 examples. 10 examples. That's a far cry from the billions and millions of examples that we often talk about with machine learning. So how do you overcome that? Well, let's talk about machine learning as at a high level, just so we're all on the same page. Oftentimes, in a very simple machine learning flow, right? You start with some data, you extract some features, take an algorithm and you apply label data to that algorithm, and you get a model. And that model is basically a representation of some sort of decision. In this case, on the screen here, it's a simple linear separator making a decision: is it circles or is it triangles? Is it X or is it Y? Is it A or is it B? So if we take that analogy and we move it to IT tickets and we look at language, we look at 6 tickets. I need Zoom. Can I have Zoom? Zoom license, please. VPN not working. How do I connect to VPN? VPN help with work from home. And the job, let's say, is this machine learning model is supposed to separate VPN issues from Zoom issues. It turns out you can create a machine learning model with just this data, and you can put that linear separator anywhere, and you'll be right, because that's all the data you have. But when you roll it out into the real world and you see the normal distribution or natural distribution, what you'll find is that your linear separator that went this way no longer makes sense, because now you have seen data that's elsewhere. And the only true answer is this decision boundary here. And when it works, it's powerful. I managed to get on the VPN. How do I join a Zoom meeting? I need to get on a Zoom meeting. How do I connect to VPN? It knows the difference. Now, the crazy thing is Zoom and VPN don't matter. Employees will throw in keywords all the time that'll throw systems off, that'll confuse systems. But that's just how people are. And we have to build systems that can overcome these limitations. So let's talk about 2 techniques of how you can do this: collective learning and transferred learning. Let's start with collective learning. Collective learning is this concept that we can aggregate information across organizations so that we can actually fulfill our need for lots more data. Here's how we do this. 3 organizations, A, B, and C. The first one uses Zoom, the second one uses WebEx, and the third one uses Google Hangouts. These are examples of, call it 12 or 15 tickets. And it looks like they're all very different. If you were to train a machine learning model, it's like, well, would we really understand the language patterns in here? How do we work with this? Well, here's what you do. The first thing is you abstract the video conferencing app. You tokenize that. All of a sudden now these sentences aren't all that different. They're still different, but they start to have some commonalities that you start to point out. You do this and you keep iterating on this, and you start to abstract all the aspects of these sentences from there's a person listed here or named here. There's a piece of software name. There's a verb, etc. And then you can take this and you can permute it such that you can generate synthetically 100,000 variations of these 15 different sentences. And then you could train that, or you can use that to train your machine learning models. All of a sudden, your precision and accuracy go up dramatically, even though you haven't seen a lot of data. But it's by aggregating data and then getting the confidence in what you're seeing that you can generate the synthetic data. Here's a quick understanding of what that impact is. If you're just training on your own labeled data, you'll have a certain precision curve. The y-axis is the precision. pretty good, but you still had to label 1,000 tickets. You had to do a lot of manual work. But if you just train across organizations and use this kind of technique, you can see that the precision curve for the whole duration from having no label tickets to 1,000 is actually better in all cases, even at the inception point. The second technique I want to bring up is transfer learning. And this is something that's relatively new, where people are using other data sets to inform existing data sets to make their understanding better and smarter. Let's suppose you're starting with a specific domain. In our world, it's IT support tickets, could be anything else, but you look for a tangential domain that's very similar but different. And you take from there some universal knowledge that can be extracted from those models, and you apply it back into your specific domain. What does that mean? Well, let's go through the journey with Moveworks for a quick second. When we started building this framework, we realized there weren't enough IT tickets that we get a hold of to actually really get good at this. And one of the things we have to get good at is understanding the shape and the nature of what employees are saying and what a good answer is. And so we went to the internet, and we found out that there's another place that people ask questions and get good answers, and that's Stack Overflow. Millions and millions of examples, not 10,000, not 12,000, not 200, right? And we could learn, oh, a good answer has these sorts of characteristics, instructions. They have a bulleted list. They have, click this, do that. And we can use that technique to then find certain characteristics. And these are one of thousands of techniques that we use, but this allows us to transfer that learning right out of the gate. Day one, we have instant value. So the next thing I want to talk about is sort of the next important paradigm with making knowledge workers more productive and effective. And that is, you have to communicate in the way that they want to, on their terms. You can't have them you can't force them, at gunpoint to say, hey, go do this or go do that. People have tried, but people will tend to just do what feels natural. And so I think for us, what we found is that employees get very frustrated with this scripted game of 20 questions with bots and other sort of systems. What they'll end up doing is just emailing IT and saying, hey, forget about it. Okay, so most chatbots that you've interacted with are actually built on a rules engine. It's a dialogue builder on the back end, and there's a if this, then that, or yes or no. And it continues to expand depending on the different flows and different use cases. And there's some logic trees that may make sense. But as they get further and further into it, they realize, oh, wait, I can't have this bot do everything because it'll get too complex. And then there's feedback loops, and then it just gets really messy. And so what we found is that you can't take this approach. You actually have to use machine learning to make the decisions around what to do next. You have to use NLP on the fly to decide what to do next, not have it be prescribed by a bot designer. Okay, so what does this look like? Well, here's 3 examples of a user talking to, in this case, the Moveworks chatbot, saying different things, but they're going to start off with the same thing. So the first one here, Alex is saying, what's the status of my headset? And the bot comes back and it says, the microphone on my headset is broken, and it pulls up a ticket that Alex had submitted. Good answer so far. What does Alex say next? I also need WebEx for making calls. Switches context, didn't say start over, didn't hit cancel, and the system says, okay, do you want me to get you WebEx? Seamlessly just switches gears, just like you type in a search engine, your UPS tracking number, or you type in a sports team name, and you get the different information that you want. Let's try this again. Alex says, I need what's status in my headset, gets the same answer. That's good, that's predictable. But then he says, please expedite this. Hard for a designer to think, well, that he might ask for this or might want to say expedite, but instead we use machine learning to decide what to do next. And the machine comes back and says, okay, I've drafted a comment for your ticket. It analyzed the text, it figured out this is likely a comment, confirms that with the user, and then submits it. Seamless. Alex doesn't think twice about it, but it works really well and to kind of his state of mind. What's the status of my headset? Computer comes back with the same thing. Then Alex says, actually, I don't need this anymore. And it's like from a chatbot designer, you're like, what are you doing? I didn't give you that option. I gave you add a comment. I gave you close issue. But the system has to then take this and handle that, at face value, and comes back and says, okay, I've canceled the ticket. If you'd like to respond to the ticket later, use this ticket number. So this is why sort of, these things don't generally feel natural, because they haven't sort of been built with this sort of framework in mind. And, it's now finally being applied to the enterprise setting. It's now finally showing up in work environments across the country. And this is where this frontier will really start to change. So last thing I'll say here is in terms of the knowledge workers and why they're going to be the ones that win from this is because unless we can make their lives easier, right? This is sort of the goal that we all have. We won't really see big impacts in our businesses because that's where a lot of the value is being derived. Quick highlights, you go to a place like Nutanix, ask them about XBot. That's what they call Moveworks. It resolves time, their tickets from days to seconds. At Broadcom, it's called OneBot. It's reducing over 50% of all the IT load that the IT team is having to handle. Western Digital is doing the work of over 43 agents. At Autodesk, it's answering thousands of questions every month so that IT teams can work on higher order things, can work on big initiatives and big projects and migrations and things of that nature. So with that, I think we've witnessed quite a bit of a revolution over the last 3 years. Chatbots are finally working, which signals a massive shift in the work environment. And even when agents have done their best work, the industry was only able to do this in 3 days' time. AI is changing that. It's eliminating a lot of the delays and the slowdown. And the future implication of these techniques go well beyond IT support. Routine tasks across the enterprise will start to get solved with AI, freeing up knowledge workers' time around the world, and it'll turn them into a painless conversation. So with that, I want to thank you for your time and hope you've enjoyed, and happy to answer your questions.
Thanks so much, Bhavin. We've got a few audience questions. So starting with this one. So you mentioned a couple specific companies that are already adopting Moveworks as systems, but just sort of zooming out a bit, do you anticipate certain industries moving to outsource data curation more easily than others?
Yeah, I think that when it comes to this domain of IT support, it is a fairly universal and homogeneous problem. So we do see quite a bit of openness and acceptance of bringing in data from the outside or learning or training on data from the outside. Because let's be honest, every morning, every IT team is solving issues with Zoom, GoToMeeting, WebEx, or BlueJeans, right? MacBooks, Dells, Lenovo's, or HPs, Salesforce, HubSpot, Dynamics. So the homogeneity makes for this to be something that's very similar. And so as a result, we've seen the same issues across very different industries, from pharma to high tech, to staffing companies, to retail, because from a knowledge worker standpoint, it's all very common.
Great to know. So it sounds like it'll be widely applicable, which is good. Now, is there a significant computational time cost for effective collective learning? You'd mentioned some more unique strategies in that way. How quickly does your system optimize on the right set of answers?
Yeah, so there's a lot more that I'd love to talk about in terms of how we operationalize this. And I think that's where a lot of the differentiation you're going to see in companies. There's a lot of companies that just sell tools and sort of hope for the customer to go figure it out and kind of get things to work. And there's others that take more of a strong AI approach, which is what we've taken, which is, hey, look, it's our problem if we don't resolve X number of tickets today at Broadcom. It's our challenge if we don't resolve certain tickets at LinkedIn. And so there is a lot of computational work that's done. There's stuff that's done offline. There's models that are trained. There's deep learning models that we apply. There's real-time models. There's feedback we get from the users that's occurring. But there isn't one technique that's solving this. A simple thing like, hey, how do I add Irina to the sales alias? As simple as that sounds, could take 14 models that all have to interact. And we're watching those performance, the performance of those, and we're swapping things out. We might have to retrain things and so forth. So it is expensive. It is expensive, not just from a computational standpoint, it's expensive from an operational standpoint. But at scale, it starts to become very efficient.
Absolutely. Now, speaking of the complexities, is there at any point that you anticipate a human really needing to get injected into the loop? Are there any security implications here when you've got a bot that's interacting between client and support?
Yeah. So we don't do any human in the loop in sort of real time. What you saw was some examples. Full kind of overview would be more informative. But what we do is if the system cannot understand what you're saying, it defaults to sending the ticket to an agent. And in some environments, you can just click on a button and go to a live agent. It turns out, though, as we've seen shelter in place come in, to picture, obviously tech bars, the walk-up bars are dead in enterprises, so that's gone to zero. We would have thought more people would be sending emails and pick up the phone. People actually don't want to do that. They want asynchrony in sort of their support. They don't want to be synchronously waiting and sort of sitting there. So what they do is they'll actually just tell the bot something, ask the bot something. The bot doesn't understand. It takes that ticket, sends it to the right agent, and the agent then gets back to the user in hopefully a faster period of time than before. So there's different alternatives, but yes, there is some cases where people are like, hey, just send me to the agent right now, and I'll explain it further.
Great. Well, thank you, Bhavin. That was absolutely fascinating.
Great. Well, thank you, everyone. Appreciate the time.
Absolutely. And attendees, thank you for your engagement on Slido and your great questions. If you'll be joining us for our final session, go ahead and follow the link below the stream, and we'll be starting in 5 minutes at 11:30 a.m. All right.